Yeah, hey everybody. My name's Greg, CTO at ChainSafe. And I'm going to be talking about, not necessarily talking about MEV specifically, but talking about how you need to think about MEV when building applications. And specifically in the bot realm. And that's because we got burned 2 weeks ago. Not hard, but we had some software that had some hiccups, and it was an interesting learning experience going down it. So we're going to talk about MEV gas killer. So yeah, welcome. I kind of gave my intro already. Cool. So thanks to Mark. I don't have to do as big of an explanation as expecting, but really simply put, minor extractable value. It's really just an understanding of the measure of how much profit a miner is taking by basically rearranging what transactions they prioritize in a block versus the traditional way nodes typically work, which is, they take the most expensive gas transactions and order them in that way. And with MEV, they're basically reordering them however they choose, typically because they get paid out by somebody else. Cool. And here's a really nice graph from James Prestowich. Shout out to him. This is like 4 years old, but he was ahead of the game. If you want like a visual understanding, the idea is, typically, in the block, a certain transaction would have come before. And like with the sandwiching that Mark was talking about, you can kind of see here how before, technically, unlock 5 ETH should have happened beforehand. And because you swapped the transactions, the user is only able to unlock, the user is able to, get ahead and do whatever they need to do. This is really out of context. There's a paragraph with it, but it was a good blog post.
Hey, Greg,
cool.
Can you just unshare and then reshare? There's like a green square around in the middle of your screen.
Yeah.
Thanks, buddy. Much better. Thanks, dude.
Yeah, cool. Yeah, so it's just basically the reordering of transactions, and it becomes it's not really a big problem in some cases. If you don't really care about the order of your transaction, this really doesn't matter. If you're just trying to get into a block, in some cases, like in bridging, for instance, which is our software that kind of like had this interesting situation, we just care that it gets included in a block relatively quickly. We don't care about the order and whatnot. So for a lot of people, that doesn't matter. If you're doing, high volume trading on like Uniswap or whatever, and you're going for arbitrages, then yeah, this is a big deal for you. But what I'm going to talk about is like for the people that think it doesn't matter to them, and why it's important that we need to kind of keep an eye on MEV in a different angle. So, gas is right? Like you always, as the majority of users, you probably know these two screens or something similar where you get to pick the gas price, right? You get to pick a transaction, you get to choose the gas price, and you get to basically decide how fast you want to get it included. Or on the left, there's MetaMask, and you can kind of just set it however you please. And on the right is I don't know which website I used, but one of the websites that has the prices that how they assume how fast a transaction will get it. And this is normal, as a user interfacing with a DApp or whatever, with your wallet, mobile wallet, whatever it is, you really have a lot of freedom because you get to see what it is today at the time. But where it gets a little funny and where we get into a bit of a pickle, so to speak, is when we start looking to automated transactions. And that's when we have bots running. So whether that's, the keeper bots in the maker ecosystem that are in charge of like basically bidding on the liquidations, or even bots that are just looking for arbitrage opportunities between different dexes, flash bots, you name it. They have a bit of a different problem that we have to think about that I don't think a lot of people really understand the issue with it, especially when it involves MEV. And I'll give a really good example here. So basically, automated trends, when you do an automated bot, you have to actually figure out what the gas price is. There's a method called ETH underscore estimate gas. And it exists on every node. So Geth, Open Ethereum, TurboGeth, Nethermind, they all have it. And it basically takes a sample of blocks and tries to make the best assumption about what your gas price should be for a given transaction at that current time. Now the problem breaks down, and I'm going to walk through basically how it broke down for us and how we ended up discovering it. It was a little bit trickier than it seemed at first. basically, if we look at this, these are the logs from ChainBridge. So ChainBridge is our cross-chain bridging tool that basically allows you to move assets, kind of like Mark was talking, from like an L1 to an L2. In this case, this was the Avalanche bridge moving back and forth, and we started noticing something funny. So we have this concept of a nonce, and you can see at the top right corner, 1724, and it was attempting to basically start this transfer. And you can kind of see it progressing. It's like, hey, they created the proposal, and we're waiting for the finalization event. So we're waiting for it to finalize on Ethereum. And then there's a couple other proposals that happen. You can actually see at the bottom, like proposal complete, not waiting. And you can even see there's a submitted proposal, on the execution a little bit further down. And then when you get to the very last log, this is where it gets interesting. We see 1724 again, but this time it says we've exceeded our limit. So we only watch for so long before we assume the transaction is dropped. And in this case, we got to a point where it actually just skipped it because it could not find enough votes had gone through, and it couldn't find the necessary event on the contract to actually trigger. So this was peculiar because 6 hours later, all of a sudden, all the transactions flooded through. And the only thing that have changed was we noticed the gas prices were really low on all the transactions from this one time. And they actually, because of the nonce on the transactions, they actually blocked all of the transactions after it, right? Because you have to each nonce needs to go first. And so one of the interesting things we found here was that basically there's two things. One, if you're really underpriced, your node's not really going to make it to the mempool. So we didn't even see these transactions on Etherscan because some miners probably just did not even propagate our transactions because we were so drastically underpriced. So the whole situation was really weird. It was basically we have missing transactions. We don't know what nonce we're at right now on the transactions themselves. And for whatever reason, we're just constantly skipping the execution. Now, there's one thing to note. Every single relayer in the system, we have 5 at this case, 4 of them were running Geth, 1 of them was running Open Ethereum. The Open Ethereum node was working. So this led us to believe something was up with the estimate gas. And after doing some digging, we actually found that these are the results of what would have been the sampled basically transactions from the previous blocks. So what Geth and all these nodes do is they basically take a sample size. They basically say, I'm going to take 3 transactions from the last 50 to 100 blocks, and I'm going to basically use that to aggregate a rough estimate of what the gas price should be for your transaction for your transaction right now. Because I just made the estimate gas call. It's going to do this quick check and build it. What we found after doing is that the blocks that it would have chosen to sample were actually just MEV transactions. So you can see there's a lot of zeros and ones. This is this is represented in Way. So if you kind of shrink it down by a couple zeros, it's 149, 149, 149 Gwei, and then a bunch of 0 Gweis, a couple 1 Gweis. And if you kind of do the mental math here, you're going to realize that those zeros and ones are really going to drive the average down because they're doing a really simple algorithm here. It was just take 3 and calculate what it might be. So what ended up happening is actually our transactions were being drastically underpriced because Geth was taking into account all these MEV blocks, which is interesting, right? Because we assume, you go to estimate gas, you're going to get the right value. But what we haven't really seen up until really this year started to really get aggressive is the amount of MEV in every single block. Because we're talking almost every block at this point has some sort of MEV in it. And it's affecting the way the nodes were calculating, the way Geth nodes specifically were actually calculating their transactions or calculating the gas cost when giving users an estimated number. So the fix was really simple, at least so far. We're still monitoring it. Now we're just basically refiltering out the zeros and ones. We're still monitoring it though, and there's a good chance we might, my original idea was take the standard deviation after removing zeros and ones to try and really push us to that perfect sweet spot of what might get there. A little too invasive right now, but we're going to keep monitoring it to make sure, is this going to continue to be a problem, or does by removing 0 1s, do we actually stabilize the gas fee? because actually the same day that I went to go make this fix, there was like 3 or 4 issues opened up because people were experiencing very similar behavior. They just didn't get down far enough in the rabbit hole to understand why it was happening. And yeah, so kind of, as I said, it's something that we're continuing monitoring, and it's an interesting situation because, as I said, you could be writing a bot any day. You could be writing a bot for whatever reasons. And if you're making an assumption to call estimate gas against your own node, against Infura, against whoever, you need to be certain that one, there's something a little bit more going in there, that they're weighting it a bit better. And also two, you need to make sure that like you're not getting invalid results. You almost have to do a double check. And that's kind of like our learning lesson here was, if you're going to go and build any sort of automated transaction system, the real solution here is probably, if you want to go to the decentralized way, which you really should, is you should be asking the node, not some third-party provider. But because of the immense amount of MEV we're seeing in blocks nowadays, it's actually probably makes sense for you to maybe even just query the third-party provider as just a fallback, just to make sure, am I like in a good range? Because if you don't, and you end up falling, gas is at 200 like it was when we were dealing with it, and our transactions were estimating around 80, 90, your transactions aren't even going to show up on Etherscan. It's going to become really confusing. And it doesn't show up on Etherscan because I said before, nodes are just filtering it out. They're just basically saying your transaction's so underpriced, I'm not going to keep it. But your local node that you're running is going to keep that transaction, continue to try to propagate it, saying like, hey, somebody, some miner, please pick it up. Please insert this into the next block. So it kind of gets hidden. And one of the reasons we found that too is one of the nodes flushed their node, and all of a sudden like everything started going through again because the transaction actually disappeared, and they were able to restart at the nonce that was stuck at the beginning. So kind of what's next step? Last night I kind of said I should probably, once the PR got merged in, I realized like, well, I should probably monitor to see how things are going to make sure that we're actually continuing to this is a solution that's actually being fixed. So I didn't have a lot of time to spin up my own notes. Can you guys still see my screen? I think you should be able to.
Yep.
Cool. Basically, I said, well, we should start actually tracking this, and we should actually start, thinking about, are the different versions that are running out there, the different node versions of different clients, are they actually estimating gas correctly, or do we need to go and actually look at their algorithm on how they're doing it? And track it better. So I spun up this website last night with a little like indexer in the background. It's kind of broken in some spots, but it's accurately representing the information. Basically, I didn't have time to spin up enough full nodes. It would have taken like days to actually, get that spun up, since I finished at like 5 a.m. But so some of the stuff here, the endpoints you're seeing are just like endpoints from different providers, different people. I was asking on Twitter if like anybody had open RPC connections I could connect to. But something that we can see right away is that if you guys know the based currency, they had their like sitemap open, and I snaked their RPC endpoint. So, haha, gotcha. They're actually running the latest version, much like we are, but you can see that their estimate gas is like brutally undervalued, underpriced. And this is like what I'm talking about. It's totally random. It's based on the node and how it does its sampling. We have, if you see based gods and ChainSafe Geth up here, it's running the exact same version as based gods. It's actually running a very similar version to Infura, but we're all reporting totally different values, which is expected. The sampling is going to be totally different. But if this endpoint here was being used to actually construct transactions for an automated service, they would completely be butchering them. You wouldn't get the right values. Your transactions would get stuck, and who knows? And there, it just recovered and came back. Now, something fun, if we go to this block number, I bet you Etherscan will tell us that it has a weird block. Ooh, it did not. Wait. Huh. No, it didn't on this one. I'll try this one because it was so low. A lot of them, like Etherscan now, yeah, see, there you go, unconventional ordering. So you can even see that like this was probably, because this block alone, the latest had such it was even flagged by Etherscan as like having MEV in it. this API, this endpoint right here, this node right here, was actually drastically underestimating. So moral of the story, you know, and what kind of like what we found is you're gonna, I think moving forward until MEV is actually like a little bit more solved, I don't think you can actually trust this to make gas anymore. And I know this is a topic that's been talked about a lot before, but it's something that I think is becoming a much bigger problem nowadays, simply because of how prevalent MEV is. That's, you know, only going to drastically increase here on out. And yeah, I just want to say a little thank you to Elizabeth for doing my PR reviews on the standard deviation one, even though now it's one line, but that was helpful. And Patrick from Ava Labs, you know, he helped me really debug the absolute crap out of this. And Martin, Gary, and Renee from Geth, because they were actually very swift to get this done, which was nice. It got merged in like 24 hours or something. They're very, very good about it because they saw it as an issue. And yeah, thanks for joining.
Perfect. Thank you, Greg. That was very interesting indeed. I think were there some questions? Rick Moo shamelessly plugged a gas estimation daemon tool also.
Yeah, probably worth using.
One question here from 55565555. What is a based gods?
No idea. Just some DeFi app.
And then here, Brandon Best was really happy to see that you're using Brave. So
nice.
And then here, a question from Aiden. Does this mean I should be using estimate gas for a specific node version in mind?
I think Open Ethereum is the most reliable right now, based on what I've seen, which is ironic at best, but it has the most reliable one I've seen. Geth is cutting a new release, I think in a couple weeks, so that'll have the fix in it. But
what I meant more is that, like, when considering what the estimate gas will be, and automating my response, the node in which
you should just use Rick Moo's tool. Should just use Richard's tool and blend it with like a third-party API and just make sure they're like kind of close to each other for safety.
Everything always comes back to Rick Moo.
It always is. Guy like solves all problems.
Cool. And then one more question from Antoine. Does this happen on other chains too, or just ETH?
I don't think other chains really have MEV because they're, you know, ghost chains. So, yeah.
Zing. Cool. Thank you for that, Greg. Appreciate it. Fascinating talk. And also special thanks to everyone else too that helped you, including Elizabeth, who's with us today.